This is one chapter of a long DVD video that brings all the various electric locomotives used by the Milwaukee Road in their mountainous areas of the Pacific Extension. Let's look into a few of them, beginning with this Quill built by Baldwin Westinghouse in 1919.
A pair of Joes, or the equivalent in box motors, could handle trains of a half-century ago. By the late 50s, a single diesel helped a pair of Joes on many freight trains. This extra power was used to help keep more competitive freight schedules. By the 70s, the electrics were often helpers to large sets of modern diesels. The old plan was to use all electric power from Harlanton, Montana to Avery, Idaho. Mixing steam with electrics was undesirable for this territory, but diesels were in fact capable of intermixing once the Milwaukee added diesel controls inside electric locomotives. This would prove to be very flexible in the last decade of electric operation. This allowed large sets of diesels to run the entire way from Illinois to the Pacific. The Rocky Mountain Division's two toughest grades in the red outlined areas would often be the only places needing electric helper power. The nagging problem of the unelectrified gap weakened the value of the electric operation. The electrics were rapidly becoming the helper sets for dieselized trains. As more diesels were incrementally brought in, the demise of the electric operation was almost a foregone conclusion. A group of SD40 or 45s or similar diesels could handle most any train in the Rockies with a boost from a single little Joe electric as a helper, and the diesels could run through the electrified gap with its easier grades. The substation capacity reflected anticipated needs of 1920, not 1970, and its heavier trains and faster schedules. Without careful application of the throttle and coordination with the substation operators, the Joes could overtax the system. The World War I vintage GE box cabs were wonderful machines, lasting far longer than anyone had expected. However, even the resourceful Milwaukee couldn't keep them running indefinitely. The rebuilding of the 50s extended their life. Years of cannibalizing parts and using home-fabricated replacement parts kept a shrinking number of box cabs running until the frames finally suffered from metal fatigue. Typically, about 12 sets of box cabs supported the Coast Division, and 9 sets were in the Rocky Mountain Division, but these numbers were thinning every year from retirements. The EF4 class Little Joes were simple, straightforward machines stretching almost 89 feet in length. They were designed for the aero straight tracks and modest grades of the Siberian line in the Soviet Union. The Milwaukee Road adapted the design to make them into heavy hauling mountain locomotives. The only flaw in this was the limited capacity of the substations when supporting 2 Joes at once under heavy loads. This diesel-powered train has a pair of mid-train diesel helpers. Every locomotive is from General Motors' Electromotive Division. This little Joe on the point shows the blanked-out B-end cab that made the 12 Joes single-ended by 1964. After that, they needed to be turned at the endpoints just like an ordinary diesel or steam locomotive. The change allowed some troublesome electrical equipment to move into the cooler cab area for better reliability. The orange and maroon colors changed to orange and black at the same time. The new colors were more consistent with the paint scheme in use on freight diesels. The mid-train diesel helpers on this train indicate the changing scenery at places like Avery, Idaho, with diesels lined up for helper service. The original speed rating for the freight box cabs was 35 miles an hour. Higher speeds caused too much stress on the rotating armatures of the electric traction motors. By the 1950s, this low speed was just too restrictive for modern railroading demands. So the top allowed speed was raised to 45 miles an hour. This was possible by the Milwaukee electrical engineering efforts to redesign and reinforce the armatures. High-priority trains tend to be overpowered to eliminate the time wasted using helpers. If a train needs helpers in the Rocky Mountains, it's already likely to be a lower priority train. However, the 45-mile-an-hour limitation still fit many situations. Let's look at the tonnage rating on a heavy 2% grade. The 5,500 plus horsepower Joes had gear ratios for use up to 70 miles an hour, and they had a rating of 1,600 tons on a 2% grade. A pair of box cabs had a 1-hour 4,100 horsepower rating. They could handle 1,500 tons up a 2% grade. A trio of box cabs was rated at 2,250 tons. The large 4-unit sets were good for 3,000 tons. Between St. Regis and Deer Lodge, an eastbound set of 4 box cabs could handle a 12,000-ton train, considering the easier 0.4% grade. This was an impressive figure for a design that began life on the drawing boards in 1914. The box motors had good adhesion to the rails when starting trains, and they were generally more useful at low freight drag speeds than the speedier Joes. The Joes had a reputation for being slippery when starting up heavy trains. The GE box motors were also equipped with secondary throttle controls to allow one engineer to run a box cab set with trailing diesel locomotives. This was designed by Lawrence Wiley. Wiley ran the electrification department from 1948 to 1956. He stayed on for many years as a consultant to the Milwaukee on keeping the electric system running. As late as 1968, he worked on proposals for bringing in new electric locomotives. Technology had moved way beyond 3,000-volt DC power. New locomotives would need a complete revision of all the substations to be efficient. It became easier to bring in a few new diesels at a time over a number of years rather than sign up to an expensive commitment for a fleet of new electrics. Plain-looking box cabs were great for freight drags and mid-train helpers, even in the more modern context of the 60s and 70s. They were easier on the old substations than the higher-performance Little Joes. The Milwaukee raised the allowed maximum voltage to the overhead to 3,300 volts to better accommodate the Joe's maximum performance. Each Joe was capable of 5,860 horsepower for up to 1 hour and continuously at 5,550 horsepower. The Milwaukee was very fortunate to buy 12 Little Joes at surplus prices in the early 50s. Replacing the rest of the aging electric fleet had become out of the question. The familiar General Electric became a major diesel builder by the early 60s as well. The Center diesel is one of GE's diesel offerings. The fall off in electric locomotive sales put them in the custom-built category. Diesels were a commodity item that had far better pricing. The Milwaukee faced a lot of problems. The line poles were in serious need of replacement. The World War I era substation equipment was becoming outmoded and difficult to maintain. The entire electric operation on the Milwaukee was living on borrowed time by about 1960. In a few more years, diesels would be offered that could match the power and tractive effort of the electrics. The station at Deer Lodge was parallel to the Northern Pacific Station and its main line that paralleled so many Milwaukee miles. The Northern Pacific had become part of the huge BN, or Burlington Northern system, that unified all the old James Hill legacy lines. It seems clear now that when the BN became everything promised, it had a profound effect on the Milwaukee. GE switcher E80 was one of 4 in its class. One was assigned to Deer Lodge to switch the large yard there. The V-shaped rabbit ears formed a spark gap to absorb nearby lightning hits that could overvoltage the unit. The V-shaped item acted like a Jacob's ladder to carry the spark away on heated and rising ionized air. The trolley pole-like device is to power the air compressor on a parked unit so the pantograph could be raised by air pressure. A sister unit, E82, also of 1917 vintage, would be the last electric unit to touch energized catenary wire on June 16, 1974. The Coast Division had already retired electric operation in 1972. Deer Lodge Yard was once a classification yard at Point where east and westbound trains had cuts of cars reblocked for outbound trains. The best the Milwaukee could hope for was that all the electrification equipment would wear out at once. This would squeeze the last useful years out of the electric era. It's interesting to note that the Little Joe Electrics made the modern trailing diesels work better on heavy grades by helping them transition to a track speed more suitable for the diesel's traction motors. The line poles had all rotted out at the bases by the 1930s. They were reinforced with stub poles sunk into the ground alongside each pole. This lasted into the early 70s, but all the poles would need replacing again, as well as the overhead wiring. The track was in terrible shape, and there was a paucity of funds for any of these replacement programs. The train's rattling substation windows, such as Drexel's, would soon be powered only by diesels that carried their own means of making onboard electric power for their traction motors. This charting is of the very last train powered by the Drexel substation on June 15, 1974. An era had ended along with a number of specialized jobs. The trains would be around for a few more years behind diesels. The end of the electric operation brought the closing of all the substations, and the Boxcabs and Joes were parked in place. The overhead wiring was torn down for the scrap value of the copper. The rotting poles were left in place, with bits of clipped-off wire poking into the air. All the equipment in the substations was removed for scrap, and many of the substations were knocked down to reclaim the bricks. The BA&P was the early pattern for electrification, and now it would help carry the long-term experiment away. This removal, cleanup, and picking up scrap pieces shows a borrowed BA&P hopper. The BA&P itself was dieselized by 1967. An assortment of oil embargoes in the 70s validated the electric power one last time. By then, the Coast Division electrification was already gone. The Rocky Mountain Division's electric system working alone was not a real solution to the oil problem. The 70s brought a rising cost of diesel fuel, a fall-off in business by 1977, unaffordable interest rates for improvement loans, and tougher competition from BN. Train wrecks came with alarming frequency on the Pacific Extension. The road did the best they could with what they had, but it wasn't enough to allow the Pacific Extension to stay open. The extension was closed for good in 1980. The Milwaukee carried on without the Pacific Extension as a Midwestern railroad until 1985. This fateful year brought the end of all Milwaukee Road rail operations system-wide. A hoped-for merger never came. No federal rescue was provided, such as the one that helped the Penn Central become Conrail. The ending left some significant things for admirers of the Milwaukee. Enough has been preserved to keep the legend alive in our minds. Collectors are active preserving timetables, postcards, photographs, and anything once used on the Milwaukee. A few of Milwaukee's Joe's box motors and a single bipolar unit are preserved on display. None of the electric switchers or Westinghouse Quills survived the scrappers. But a box motor from the BA&P is in Butte, Montana, displayed with other museum items associated with the copper mining days. The beautiful station at Missoula became a restaurant, certainly a far better status than being converted into a pile of salvaged bricks. The states of Washington, Idaho, and Montana have preserved some of Milwaukee's structures. Many of the Milwaukee's miles have been converted into trails that are accessible to the public. The appeal of the scenery that sold passenger train tickets is still there for people to enjoy. You can still walk and ride over spectacular bridges and pass through tunnels in rugged mountains. Tours are available, and many special locations have permanent signs that explain how things worked in the electric railroad days. The Milwaukee once had a grand idea. The major obstacle of a mountain range can also trap snowfall, lifted up by nature, and turn its runoff water into the energy to power a train. They knew that a mountain was both the obstacle and the solution. Some critics called the Milwaukee's Pacific Extension the world's longest branch line. This will fuel debate for years to come over the wisdom of building America's last road to the Pacific. In 1869, the opening of the distant Suez Canal in Egypt coincided with the linking of the Union Pacific and the Central Pacific, America's first road to the West Coast. With the canal, European ships would not be tempted to use U.S. rails to forward goods to West Coast ports for Asian destinations. It had a slowing effect on the line's success. The 1914 opening of our own Panama Canal blunted the value of this east-west line to the Pacific. Shippers in the East would not necessarily need rails for Asian destinations. We will never see scenes like this again. They were unique to the Milwaukee. It's astonishing that a railroad its size could just disappear.
Be sure to like and subscribe. It helps bring more content to YouTube. The full video also brings early steam and the diesels that replaced everything else, as well as regional competition in the West. See the electrification from the road's innovative beginning to the end, including how the system was built. Don't miss out.